Welcome all. In this video, we are going to see how to plot the input and output characteristics using LTSPICE. For that, open LTSPICE. You will be getting the window like this. Then go to File, View Schematic, and go to the component. And we need the NPN transistor. So I am typing NPN and click OK and place the NPN transistor. And we need the resistors. Rotate the resistors like this and keep wherever here the resistors. And then we need the component voltage source. Two voltage sources, right? One is for VBE and another one is for VCE. So two voltage sources I am placing over here, and I am taking the ground, so this is a ground point. So place wherever we require. So we require 3 ground points over here and give this key. And now take the wires to connect and connect it with the help of the connect the components with the help of the wire. You can drag and you can click like this to connect. After wiring the components, if you want to go to the next mode, just press escape, it will switch over. And now we have to give the values for the resistance. So I'm going to give the value as 1 kilo ohm here. And I'm going to select this specific transistor. So it is an NPN transistor. So what type of NPN transistor I'm going to pick is BC547C. You can right click the transistor and you just select BC547C and give OK. And give the resistor value over here also. So here I am going to keep some 60 kilovolts like that. You can change the resistance values and also you can observe. I am going to name this supply voltage as VBE. I am going to name the supply voltage as VCE. Yes. So transistor, base terminal, emitter terminal and collector terminal. So it is a common emitter configuration we are going to do. So I am grounding the common emitter terminal. And I am taking VBE supply voltage and VCE supply voltage. Now we have to plot the graph, right? So after doing this, so you just click this, go to run and click DC sweep. So why we should click DC sweepers? So if we do it, if we want to change the VBE, right? If we want to change the VBE, and we have to observe what is the IB, for different value of VCC. So you can have a look at over here for input characteristics. What we have to do, we have to fix certain VCE voltage, and for that we have to vary the VBE base emitter voltage, and we have to observe the base current, right? And we have to plot the characteristics between the base emitter voltage and how the base current is for different VCE voltage. So this is what we are going to perform over here. So for that I am going to keep my VCC as 1 volt. So and I am going to change. I have to change the VBE, right? VBE is in the x-axis. I have to vary the values of the VBE. So what we have to do is we have to sweep the voltage over here. For this, click run, and go to DC sweep. So the source I have to sweep here is VBE. So I am writing VBE over here. So I am going to sweep it in linear manner. So I had clicked linear over here, and we need a start value. I am going to start with 0 and I am going to stop with 1 volt. But I am going to increment as 0.1 volt. Yes, 0 to 1 volt volt, and I am going to increment in the steps of 0.1 volt. So you can also write the directive like this: dot DC VBE 0.1, okay, directly over here also, okay, or else you can select this and you can give it like this. So we will be getting a chart like this. Yes. Now what is the requirement? You can look at here. We are getting the VBE voltage. It is varying from 0.0, 0.1, 0.2 the levels up to 1 volt. Now what we have to plot? We have to plot the IB current, right? And already I had set the VCE voltage as 1 volt. Okay, you can look at here. I had set the VCE voltage as 1 volt. Now we have to plot the IB current alone, right? So I am going to click where IB current I will get it at the base terminal, right? I can measure. So here you can have a look at practically what we are doing is we will be connecting an ammeter to the base terminal and we are measuring the IB current. So instead of connecting an ammeter, so this red probe will give you the measurement of voltage, and this clamp probe will give you the measurement of the current. You can click the clamp probe over here. Okay, you can look at how the curve is. Okay, after 0.6 volt, we know that after 0.6 volt of VBE, so the current IB would try to increase. Okay, so that is what we are getting over here. Okay, so you can you want to measure another two values of VCE. Okay, we only need to measure another two values of VCE if required. So we can change this VCE voltage as also to sweep. Okay, how can we do this? You can right click over here. You will be getting sweep, and we can add the second source of sweep voltage over here. So that is VCE. Okay, and I'll give the start value as 1 and stop value as 3 and increment as 1. So for 1 volt VCE, for 2 volt VCE and 3 volt VCE, we will be getting the curve like this. Okay. Okay, and we can also change the values up to maximum values to 3 over here. Okay, and again click run. Okay. So we are getting very short interval. So we are getting on the same dot but in different colors. Okay. So now you can also, if you need, you can change the voltage also over here. Okay. You can click right click. Okay. For instead of 1, you can go with the 7 or 8, and you can go with the increment steps of 2 like that also. Here again you can change the value as maximum value as 7 also. Like this. You can see the several colors here. Okay, and all are going to rise at the level of 0.6 and going to get incremented. Okay, so this is what the plot we require for the input characteristics curve. Okay, by varying VBE, you are measuring IB. Okay, so VBE is base emitter voltage and IB is a base current. Okay, when the IB start to increase, okay, when it crosses the depletion region, okay, when it breaks down the depletion region, the current will get increases, right? So that is what after 0.6 voltage, after the threshold voltage, okay, then the current is getting increased over here. That is what we are going to analyze from this input characteristic curve. Thank you. In the next video, we will do how to measure the output characteristic curve. Welcome back. In the previous video, we were plotting the input characteristics of bipolar junction transistor. Now we are going to plot the output characteristics of bipolar junction transistor. Before that, let us look at what is the output characteristics we have to do. So this is output characteristics of the bipolar junction transistor. Output characteristics is the curve which should be plotted between the output voltage VCE in x-axis and output current IC in the y-axis for different levels of the IB. Okay, for output voltage in x-axis and output current in y-axis for different levels of input current IB. So this is what we are going to do, and this is the tabulation for different input currents. Okay, so let us plot this circuit diagram in the LTSPICE and we will simulate the output characteristic curve. So as we know how to pick the component and place, and we can construct the circuit diagram. Okay. If you are not aware, please do refer the previous video. We had plotted the circuit diagram for the transistor characteristics, and here we know that this is the base terminal and emitter terminal and the collector terminal. So this is common emitter, so all these points are grounded together, and we need a voltage source VCE. Okay, so this is an output voltage source and VB is an input voltage source. What we are going to do is we are going to plot the characteristic curve between VCE and IC. Okay, by variation in IB. Okay, how can we do this? Okay, so first what we know, we need in x-axis we need to plot VCE, right? So for that, go to run and go to DC view, and what we required in x-axis is VCE. Okay, so select the source as VCE. Okay, and linear, and start the values from 0 to 20 volts. Okay, in the increment of 1 volt. Okay, click OK. And then what we need is, okay, we want to measure the IC current, right? We have to measure the IC current, so you can place the clamp over here. Okay, you are getting the IC current like this. Okay, so but we have to maintain different input currents. Okay, how can we maintain different input currents? IB, how can we maintain? By giving some voltage in VB or VB only we can able to maintain that. So click this. Okay, now I am going to fix the voltage to certain level as 16 millivolt. Okay, and again max. Okay, now we are getting a curve like this. So where the x-axis is what is VCE, okay, output voltage VCE, and the y-axis is what we are plotting here, IC current, collector current we are going to measure here. But we need different values of VBE, right? So here only one fixed value we are taking. Okay, by keeping the VB as 600 millivolts and resistance R1 as 2K, we are only getting certain current IB. Okay, for that current only we are going to have a single curve over here. So we have to measure for different values of IB. How can, so we have to sweep the values of IB. How can we sweep the values of IB over here? So you can click here and you can click the sweep. Okay, now we are going to click the second source. Okay, what is the second source? So it is a VBE. We can't directly sweep the IB, so I am going to change the VBE in this sense. Okay, by changing the VBE we will get different IB values. So I am going to start with 500 millivolt, and here I am going to enter 600 millivolt over here, an increment of 20 millivolt. Now I get approximately, I get nearly 5 readings. Okay, so I will get 5 different curves, output curves for this. Okay. Now you go to run, okay, and separate. This is the output characteristics of bipolar junction transistor. You can get different 5 values for different IBs. Okay, all the students are requested to do the experiment. Okay, all the students, you must do the experiment in LTSPICE 2. Okay, and simulate the same by changing the different values of VBE, VCE, and different sweep values. Okay, by observing this demonstration videos and try to change the resistance values and VBE, VCE values and different sweep values, and try to submit the laboratory experiment. Thank you for watching.